Hi guys. Hello Viraj. Hello Reena. How are you? I hope you are enjoying the sessions, right? So welcome back. Gabbar is back again with another session of JEE Advanced Aspire, that is Mechanics 2. उस दिन कुछ क्वेश्चंस टाइम की वजह से रह गए थे, तो उनको कवर करने के लिए दोबारा मैंने एक सेशन फिर से प्लान किया है, दैट इज़ द मैकेनिक्स 2. आगे वेरी गुड इवनिंग अजय, वेरी गुड इवनिंग फरहान मलिक, श्रीशा, हर्षित, रेड्डी, रूपम, हेलो, नेमी, फरहान. ओके, सो इससे कुछ पता लग रहा है क्या करने वाले हम लोग इस बॉल से? कुछ अंदाजा लगा? हाँ, क्या हो सकता है इस बॉल से? व्हाट वी आर गोइंग टू डू विद दिस? थैंक यू, थैंक यू. सो गाइज वेरी गुड इवनिंग. सो चलो शुरू करते हैं. अब मेरे बारे में यार बहुत सारा जानते ही होगे तुम लोग. विदाउट वेस्टिंग टाइम लेट्स स्टार्ट अवर दैट JEE एस्पायर सेशन. एंड दिस बॉल इज फॉर जस्ट इम्पल्स एंड मोमेंटम, जस्ट deformation and reformation. Okay, so with the help of this I am going to tell you what is actually the deformation and what is actually the reformation, how the body deform, what is the energy of deformation and what is the impulse of deformation, impulse of reformation. All these things just we are going to study till now. तो आज बैंड बजाएंगे, ब्लास्ट करते हैं इम्पल्स एंड मोमेंटम में, क्योंकि सबसे ज़्यादा गलतियां, और स्पेशली मैंने वो सारे क्वेश्चन लिए हैं जहां पर आप डेफिनेटली इम्पल्स मोमेंटम में डायरेक्शन की, मोमेंटम की, इम्पल्स की गलती करते हो. यस अजय, चलिए शुरू करते हैं. यस, केमिस्ट्री क्लास भी होगा, डोंट वरी गाइज. पहले फिजिक्स पढ़ो. तो ये जो इम्पल्स मोमेंटम है उससे पहले चलते हैं हम लोग. एक पहला फर्स्ट क्वेश्चन ऑन द स्क्रीन देखो ध्यान से. फर्स्ट क्वेश्चन इज देयर. सो अ वेरी इजी टाइप ऑफ क्वेश्चन. जस्ट यू हैव टू क्लियर, यू हैव टू जस्ट रिवाइज योर कंसेप्ट. So see what is the question. The question is, my dear students, a particle A of mass 2 kg. Guys, are you ready? Are you ready? Okay, so चलो एक बार क्वेश्चन पढ़ लो. अब मैं कैसे हटूं यहां से, ऐसे होता हूं, तो एक बार क्वेश्चन पढ़ो. क्वेश्चन क्या है? पार्टिकल ऑफ A mass 2 kg. See, mass 2 kg lies on the edge of a table and height of that table is given as 1 meter. Okay, and it is connected with a light string. Light string means mass of the string is almost 0, and inelastic string of length 70 meter to a second particle B of mass 3 kg. Guys, okay, so what happened when you just push this? It will drop from here, and after what distance the string become taut? After what distance? कितनी डिस्टेंस के बाद ये स्ट्रिंग आपकी टॉट हो जाएगी? कैन एनीबडी टेल? जस्ट पुट इन योर चैट. आफ्टर हाउ? बिकॉज दिस डिस्टेंस इज 0.25 and the length of this string is 0.70 centimeter, meter. Means you can say this is 70 centimeter, right? 0.70 meter, here 0.25. So anybody? Yes, 45. So 0.45 distance it has to cover. Okay, so what is the velocity gain before, just when the string becomes taut? जैसे ही string taut होने वाली होगी, just उससे पहले इसकी कितनी velocity होगी? Yes, very good, under root 2gh. So you can say root 2g is equal to 10, h is equal to 0.45. So 10 into this is 4.5 into 4.5 into 2, 9. So velocity is equal to 3 meter per second when a string just about to taut. Good. Now after that what will happen? Yes, this is 3 meter per second. Very good. Karthik and other one, all are very good. Correct answer. Now what the question taught? What is the impulse imparted to the string? So what will happen? See here, when this is 3 kg and after this is 2 kg and its velocity is, suppose v is equal to 3 meter per second. So just string, जैसे ही string tight होगी, taut होगी, वैसे ही वो दोनों मास चलने लगेंगे. Now अब इसका जो मास का velocity होगी, इसके बाद let v dash and this should be v dash. Now what we have to do? Impulse, because on the system there is no any external force. If there is no any, yes, change in momentum, and that is change in momentum due to what? किसकी वजह से आएगा? That is by the impulse. Impulse momentum theorem, that impulse is equal to change in momentum. So let's say what is the next momentum? So 2 into v dash plus 3 into v dash, initial momentum is 2 into 3. After that 3 plus 2 means 5 into v dash. So what should be the v dash? Is 6 by 5 meter per second. So when a string will be taut, both the block will move with this velocity. So how the impulse you can calculate? This is the impulse, okay, imparted by the tension, and that impulse is equal to change in momentum of that or this. Okay, so if we calculate this, you can say here impulse t into dt, change in momentum is final minus initial. So what is the final momentum, bachcho? What is the final momentum? Initial is 2 mass and final velocity is 6 by 5 minus, you can say, the initial velocity. What should be the initial velocity? Initial velocity कितनी थी बच्चों? Initial velocity 3 थी, और यहां से आप कह सकते हो 2 into 5 3 15. 15 minus 6 is equal to minus 9 divided by 5, and now you can say minus 18 by 5. So what should be the value of y? See here, it is 3 lambda by 5. So we have to find the value of lambda. So lambda की वैल्यू कितनी आ गई? बोलो बच्चों. See, just tell me lambda की वैल्यू. Yes, अजय पंडित, very good. ऋतिक कश्यप, tech minus 6. No, it's not minus 6 because the minus or the negative sign shows the direction, because the t is in opposite to the, because the momentum is in that direction and that impulse is in opposite direction, that's why it is negative. So the impulse imparted is minus 8. When you compare this, then you will get lambda is equal to 6, and here it is your answer, lambda is equal to 6. So I hope you understood perfectly. Hey guys, you got it? Very nice, very nice. बहुत अच्छी बात. कार्तिक मुरादाबादी नहीं, मुदरद्दी. Okay, 6 in opposite direction. Yes, this impulse in this direction, and if you take this impulse, so this impulse in that direction is positive. Okay, so negative sign only tells us about the direction. Here we have to find the magnitude. So with that magnitude, the value of lambda is equal to 6. Okay. No, we cannot apply the conservation of energy here, because if we apply the conservation of energy, so there is a direction. Okay, so conservation of energy not involves impulse anyhow. Here we have to calculate the impulse. तो when आप यूज करोगे जब एनर्जी, तो उसमें इंपल्स नहीं आएगा, इसलिए यहाँ पे इंपल्स नहीं यूज करेंगे, वो एनर्जी यूज नहीं करेंगे. गॉट इट? ओके, चलो बच्चों चलते हैं अगले स्टेप की तरफ. देखते हैं अगला क्वेश्चन क्या है. एंड यू हैव द नेक्स्ट क्वेश्चन. यस, नेक्स्ट another very good question. See here, the question is 2 balls. See that I'm just giving a space for you so that you can see the question, you can read the question. Okay, so read very fast dear. So let me explain. 2 balls, you can see here 2 balls having the masses 2m. See here, having the masses 2m, m and 2m, right? You can say one ball having the mass m, another ball having the mass m, here 2m and there m. There are 2 balls, as you can see on the diagram. L is equal to same length. This L is equal to 1 meter. The other end of the string are fixed at O. O is a fixed point. And when you release, see here, this is the position m and 2m. When you release, they will move like this. See this? They will move like this. And when they will move like this, they will collide at the bottommost position, right? When they collide at this position, so they move like this and it will move like this. So what is the situation? This ball has mass 2m and this ball has mass m. The velocity of this is u and velocity of this is u, because L is same. And value of u, my dear students, is equal to under root how much? 2gl. Got it? बोलो बच्चों, ये समझ में आ रहा है ना? 2gl Got it? Very good, Farhan and Karthik. No, it's not the center of mass concept, just the circular motion. So the velocity gain in kinetic energy is equal to loss in potential energy. So gain in kinetic energy is half mv square and loss in potential energy is 2 mgh. So half mv square is equal to mgh, then you will get v is equal to root 2 gl. Okay, and now let's see, is it the elastic collision or not? So you can see the question, they are colliding elastically. So this is the condition before the collision. And what happened after the collision? After the collision, you can say this mass m will move with velocity v1 and this mass 2m will back with velocity v2. And elasticity, E coefficient of elasticity is equal to, yes, velocity of separation divided by velocity of approach. Got it? Very good guys, very good guys. E is equal to 1. So first we apply the conservation of linear momentum, and linear momentum is a vector quantity. So first we have to choose a positive direction. So let's choose a positive x-axis or direction of positive x-axis as a positive, right? So what can we say for the first before the collision? You can say mass is 2m, velocity is u, minus, why minus? Guys, can you tell me why it is minus? Because, just tell me, because direction is opposite. Okay, so it's opposite direction, so 2mu minus mu is equal to, after the collision you can say mv1, and for this you can say minus 2mv2. Okay guys, now you can say m and m will be cancelled from here, and 2u minus u is equal to u is equal to v1 minus 2v2. This is supposed to be equation number 1. तो equation number 1 कहां से मिली बच्चों? Yes, conservation of momentum. And for the second equation, what we'll do? Just apply E. Yeah, E is equal to velocity of separation and velocity of approach. So E is equal to velocity of separation. Velocity of separation, you can say they are separated by V1 and V2. So the velocity are in opposite direction. So they are V1 plus V2 divided by velocity of approach. Before the collision, they are approaching like this. When they are approaching like this, the u and u is the velocity. U plus u, that means 2u. Very nice. So 2u, and it is a elastic collision as shown in question. So E is equal to 1. From here you can say V1 plus V2 is equal to twice of u. And here we have to solve when we are seeing that 2v2, so we can multiply by 2. So 2v1 plus of 2v2 is equal to 4u. Okay, so guys, this is the second equation. So now we can apply 4u is equal to 2v1 plus of 2v2. Okay guys, now you can solve this. This 2v2 will be cancelled out, and 5u is equal to 3 of v1, and we have to find v1. Why we have to find the v1? Yes, because the question asks that both the balls are released and they collide. Find the height raised by the ball of mass m. Mass m collision के बाद कितना वापस ऊपर जाएगी, how much height it can raise after the collision, and the mass m has a velocity after the collision v1, so we require to find the value of v1. And here you can say this v1 is equal to 5 by 3 of u, and you already have, that is 2gl. So now you can apply 5 by 3 अंडर रूट 2gl, और कहानी शुरू होती है अब जरा देखो ध्यान से, v1 इज इक्वल टू 5 अंदर जाएगा 25 इंटू 2 50. यस, ऑब्वियसली नाउ यू कैन से 25 इंटू 2 इज इक्वल टू 50. सॉरी, इट्स नॉट 2, इट इज 50gl डिवाइडेड बाई 9. ओके, 3 इंटू 3 स्क्वायर में 9. So this value is obviously greater than root of 5gl. And what is the root of 5gl? Guys, what is root 5gl? Root 5gl is the velocity. Root 5gl is the velocity for what? For to complete the vertical circle, right? So it has a more than velocity or greater than if we are root 5 gl, so it will move like this. So maximum height will attain is 2l. So the answer is 2l, as l is given as 1 meter, so your answer should be 2. Okay guys, what explain anonymous tech? What do you want to explain? Just tell me. Velocity of vertical motion, yes, vertical circle. If a string is there, then the required velocity, guys, root 5 gl. If massless rod is there, then the required velocity is under root 4 gl. Here there is a string, so the required velocity to complete the circle is root 5 gl, and here we get the velocity more than root 5 gl, then definitely it will complete the circle. So maximum height attained is 2l from the top bottommost point. So 2l is the height, l is 1, so answer is 2 meter. Root 4 gl is the required velocity at the bottommost point if instead of a string there is a massless rod. This is a conceptual value. So conceptual part, if there is a massless rod, then the required value is root 4 gl. Got it? Hi Abhinav, hi everybody. Videos in previous examination, please just like you above the broad for medical. I want reply from Vedantu. Hi dear, previous year questions you already have solved as a solved paper or solved question bank or solved books. Okay, so here I am trying to take those type of questions which just teach you some conceptual part. Okay, so let's say this is the first another question. आगे चलते हैं. Let's see the next part. Okay, it's a very good question. You can see here. Where is the ball? Let me. Now I need this ball for explanation. See this question. See this question. This question teach you too many concepts: deformation, reformation, energy of deformation. Yes, it's a conceptual but calculation based also. So see there, no tennis. Hey Farhan, it's not tennis. See here, two spheres are moving towards each other, right? Both have same radius, but masses are 2 kg and 4 kg. 2 kg and here 4 kg. Okay? Their velocities are not along the line joining their center of mass. So this type of collision is not the head-on collision or direct collision. What type of collision is this? Guys, just tell me, what type of collision is this? Don't know. This is the case of oblique collision. And if this is a case of oblique collision, so see what we can do here. A part, B part, there are so many answers. So many questions. Yes, oblique collision. Vedant Gupta. Oblique. Very good guys. Very good. Okay. Very nice. Very intelligent guys are there. So see here, bachon, but their masses are this. Velocities are 4 and 2 meter respectively in opposite direction, and this is not the elastic collision because coefficient of elasticity is given as 1/3. Coefficient of elasticity, so it is not the oblique collision. And now you have to find so many parts, right? A part is the common velocity along the line of impact, final velocity along the line of impact, impulse of deformation, point to be noted guys. हो सकता है बहुत से लोग पहली बार सुन रहे हो. And then impulse of reformation, deformation and then reformation. So you have to find both of the impulse and both of the energy. You can see here maximum potential energy of deformation, loss in kinetic energy due to collision, because it is not the elastic collision. That's why there is a loss of energy and you also have to find that. Okay. Yes, बहुत सारे कंपोनेंट लेना होगा और बहुत सारे कंपोनेंट अजय आपको बहुत सारी चीजें सिखाएंगे. ठीक है, डरना नहीं है, बड़ा क्वेश्चन देख के डरना नहीं है. और अगर डरे भी तो मैंने पहले भी बताया है, डर के आगे जीत है, और जीत में JEE, और आप उसी JEE की तैयारी कर रहे हो. ठीक है, तो डर के आगे जब भी जीत है तो ध्यान रखना JEE and that G you are preparing for that JEE and advance. ओके चलो यहां से चलते हैं। इजी ट्रिक ही है, मेन कंसेप्चुअल में आपको क्या है, अलोंग द लाइन ऑफ इंपैक्ट एंड परपेंडिकुलर टू द लाइन ऑफ इंपैक्ट। होगा क्या, जब ये दोनों कोलाइड करेंगे तो कोलिजन में सबसे पहला पार्ट देखो, यू हैव टू फाइंड द कॉमन वेलोसिटी अलोंग द लाइन ऑफ इंपैक्ट। सो इसके लिए मुझे थोड़ा सा डायग्राम को और अच्छे से बनाना पड़ेगा। So see, this is the type of collision, and here you can say when they collide, then the normal reaction applied along this line. So the line along which the normal reactions, external normal reactions are applying, is known as line of impact. So ये वाली line आपकी जिसपे normal reaction लगेगा क्या कहलाएगी, बोलो, line of impact। और ये जो लाइन है, ये लाइन इसके परपेंडिकुलर, ये कौन सी लाइन है, इसको टेंजेंशियल एक्सिस कहा जाता है, एंड दिस इज नोन एज टी एक्सिस। एंड देयर इज नो एनी एक्सटर्नल फोर्स ऑन एनी इंडिविजुअल बॉल, नो एनी एक्सटर्नल फोर्स ऑन इंडिविजुअल बॉल along the t axis. Okay, so if there is no any external force along t axis, then what we have to do, their velocity along the t-axis will not change because the momentum as NLM2, the rate of change of momentum is equal to net external applied force. Means the momentum can change only by the application of external force. If there is no any external force, then the momentum will not change at all. So the concept part is, yes, this theta you can say this distance is 2r, this distance is r, by this triangle you can find this theta, and this theta will you get 30 degree. I hope everybody got it. थीटा की वैल्यू 30 बहुत आराम से आ गई होगी बच्चों। How is the जोश? Yes, 30 degree. Very good guys. So if it is a 30 degree, now you can resolve those two components, one component in this direction and one component along this direction. Okay guys, so this is 4 meter per second. So here you can say 4 sine 30, one component is there, and along this line the component is 4 cos 30. Okay guys, and for this it has a velocity 2 meter per second in that direction. So you have to again resolve the component along line of action, impact and t-axis. So if this angle is theta, this angle is also theta. This is 2, so you can say 2 sine 30 at all, and here it should be 2 cos 30. Which component will not change? Which component will not affected? किस कंपोनेंट पे कोई इफेक्ट नहीं पड़ेगा बच्चों? कौन सा कंपोनेंट चेंज नहीं होगा? 4 sin 30 will not change. 4 sin 30, yes, and 2 sin 30 also will not change. Why it will not change? Because there is no any external force on a body along this axis, because the only external force acting on the body is that normal reaction, right? This is the normal reaction and it has no component along this t-axis. So individual body का linear momentum t-axis के about unchanged रहेगा, लेकिन line of impact के about change हो जाएगा। Yes, बिल्कुल सही तरुण, साइन वाले में कोई इफेक्ट नहीं पड़ेगा, कॉस वाले में इफेक्ट पड़ेगा। अब अगर कॉस वाले में इफेक्ट पड़ेगा तो हम कैसे देखेंगे निधि चौहान? चेंज होगा। वाई चेंज होगा? बिल्कुल नहीं चेंज होगा बेटा, कॉस वाला चेंज होगा। तो अभी जो अपना फर्स्ट, दिस इज एक्चुअली द कंपोनेंट्स, ओके। आफ्टर दैट लेट्स सी, ओके, 1 minute, A part. So here you can say these are the component form. This is the ball and the ball component in that direction along t-axis and this direction, and the component of ball and this and this. Now we have to find what in A direction, what is the common velocity. common velocity. This is a very important point. Okay, so let me explain what is actually the common velocity. Suppose this particular object, and here is a particular ball. They are moving like this. This is ball m1, or you can say mass m1, and moving in that direction. And this is a mass m2 moving with a greater velocity, and if it is moving with greater velocity, so they will collide like this. This is just the collision. And what will happen? They start deforming. They start deforming like this. They start deforming, right? So this is actually the maximum possible deformation. This is the maximum possible deformation. After that, when they separate, their velocity is changed, so they again reform. So now just concentrate on it. Just concentrate. It will goes like this. ये ऐसे जा रही थी, किसी बॉडी से टकराई, टकराने पर इसकी वेलोसिटी धीरे धीरे कम होती है और एक मैक्सिमम वेलोसिटी पे दोनों एक साथ चलते हैं. दैट इज अ मैक्सिमम डिफॉर्मेशन. व्हेन द वेलोसिटी ऑफ two bodies or velocity of both the bodies will same equal in magnitude as well as in direction, then there is a maximum deformation. So the state of maximum deformation is when both are moving with same velocity. After that they start reform. Right? When they start reform, and after the complete reformation they separated like this. Okay, so if they are separated, so after that separation the reformation takes place. This is the maximum deformation. When the velocity is same of both the balls, one ball here, another ball here, maximum deformation, same velocity. After that reformation takes place, and this is the complete reformation. So we have to find what is the common velocity in part A. So in part A, the velocity of both the ball should be same. So now you can say when both the ball will moving with same velocity, so combinedly their mass is 2 plus 4 is equal to 6, and with velocity v, so the momentum in that direction in that case is 6v. Okay, so let's calculate what is actually the momentum, linear momentum before the collision. Before the collision we have to choose a particular direction as a positive. So suppose this direction is a positive, and this ball has a velocity 4 cos 30 into 2. Okay, and it is in opposite direction, so that minus 2 cos 30, and its mass is 4 kg. So you can say 4 cos 30 is root 3 by 2 into 2 minus 2 root 3 by 2 into 4, and now you can say 2 will be cancelled out, this 2 will be cancelled out, 4 root 3 minus root 3, 4 root 3, it equal to 0. Okay guys, so the linear momentum, net linear momentum is 0. So when they are at maximum deformation state, their velocity is 0, means they are at momentarily rest. Last process repeat. See, this is a ball 2 kg, this is a ball 4 kg. These components will not change because they are along the t-axis. Only the components which are changed, this is 4 cos 30 and 2 cos 30. So now just applying the conservation of linear momentum. But here we are applying the conservation of linear momentum at the condition when there is a maximum deformation. And my dear students, when there is a maximum deformation, at the state of maximum deformation, the velocities of both the balls will be same. Velocity, not the speed, velocity will be same, means they are moving with common velocity, and this is the case of maximum deformation. Got it? So let that maximum deformation is what? Is V, and the combined mass is what? 2 plus 4, that is 6. So the velocity momentum should be 6V. So now check the before momentum, before linear momentum, this direction is positive. So 2 into 4 cos 30, right? 2 into 4 cos 30 here, and it has opposite direction. That's why 4 into 2 cos 30, and fortunately or unfortunately you can say this is equal to 0. It means in a state of maximum deformation, the ball will be at momentarily rest. Got it? Very good. Now let's see the final velocity. This is the A part. In A part you have to find just the common velocity. Whenever you have to calculate the common velocity means the velocity by which they are moving at maximum compression के केस का ये एक बात है. ओके, चलो अब आगे आते हैं, अगला पार्ट देखते हैं. ये मैक्सिमम कंप्रेशन समझ में आ गया. दिस इज अ वेरी इंपॉर्टेंट, और इसी से आपको इंपल्स ऑफ डिफॉर्मेशन और इंपल्स ऑफ रिफॉर्मेशन पता करना पड़ेगा. तो यहां तक गाइस क्लियर हो गया. मैक्सिमम डिफॉर्मेशन पे वेलोसिटी 0 है, मैक्सिमम डिफॉर्मेशन पे वेलोसिटी 0 है, नॉट द फाइनल वेलोसिटी 0. सो लेट्स चेक व्हाट इज द फाइनल वेलोसिटी. चलो गाइस आगे देखते हैं. फाइनल वेलोसिटी अलोंग द लाइन ऑफ इंपैक्ट आफ्टर दैट मैक्सिमम डिफॉर्मेशन, then reformation will takes place. When reformation will takes place, then both the ball has the different velocity. Both the balls has different velocity, and both the ball has different velocity. अलग अलग velocity होगी तो वो क्या होगी? देखो, after the collision the velocity is, after the collision, after the separation, when they are separated, जब दोनों अलग अलग हो गए हैं, मैक्सिमम डिफॉर्मेशन के बाद रिफॉर्मेशन हो चुका है, उसके बाद क्या कंडीशन हो रही है उसकी बात हो रही है. सो लेट आफ्टर द सेपरेशन देयर फाइनल वेलोसिटीज अलोंग द लाइन ऑफ इंपैक्ट इज v1 एंड इट हैज वेलोसिटी v2. ओके गाइज, सो दिस इज द फाइनल वेलोसिटीज अलोंग द लाइन ऑफ इंपैक्ट. And initial velocities line of impact, when we calculate the initial momentum, as we already calculated, it is equal to 0. So it also should be 0. It also should be 0. So now you can check P initial is equal to P final. Now we are going to apply the conservation of linear momentum, especially you can say along the line of impact. Okay guys, very good. ओके, अब ध्यान से देखो, इनिशियल जो है बच्चा 0 है, फाइनल देखो क्या करना पड़ेगा अपने को. एक डायरेक्शन वेक्टर क्वांटिटी है, पॉजिटिव विद नेगेटिव डिसाइड करना पड़ेगा. डिसाइड कर लिया. अगर ये पॉजिटिव है देन यू कैन से इनिशियल वेलोसिटी इज 2v1 एंड प्लस सेम पॉजिटिव डायरेक्शन, देन यू हैव टू से 4v2. गॉट इट? नाउ फ्रॉम हियर यू कैन से v1 plus 2v2 is equal to 0, equation number 1. Okay, this is just the application of conservation of linear momentum. And now we are going to apply, yes, coefficient of elasticity, right? So coefficient of elasticity E is given as, I think, 1/3 as according to the question. If it is 1/3, so we can apply E is equal to velocity of separation divided by velocity of approach, and that is along the line of impact. So E as given in question 1/3, and velocity of separation, what you can say? Velocity of separation, obviously ये जब अलग हुआ v2 ज्यादा होगा, v1 कम होगा, तो velocity of separation you can say v2 minus v1. Okay, v2 minus v1. Or before that, velocity of approach, they are approaching like this. So if they are approaching like this, so what is their velocities? One has 4, another one has 2. So one has the velocity 4 cos 30 plus another one has 2 cos 30. So 4 cos 30 is root 3 by 2 plus 2 cos 30 root 3 by 2. 2 will be cancelled out. Here 2 is to 2. 2 root 3 and root 3 is equal to 3 root 3. Okay. This is the velocity of approach along the line of action. Are you getting, guys? v1 v2 in the same direction. वो अभी आंसर से आ जाएगा बेटा, अभी अपने को पहला नहीं पता है. अजय, we don't know what should be the direction, so let assume that both are in same direction. If it should be in opposite direction, then answer should be in negative. Got it? Okay. So v1 v2 we don't know the direction, so just assume in the same direction. If it should be in opposite direction, then the answer will be negative. Okay, so let's see. This is 3 root 3. Now we can apply 3 root 3, and here you can say 3 and 3 will be cancelled out. v2 minus v1 is equal to root 3, guys. Okay, and here you can say v2 minus v1, and here you have v1 plus 2v2 is equal to 0. So v1 plus 2v2 is equal to 0, and now you can say v1 will be cancelled out, so 3v2 is equal to root 3, so v2 is equal to 1 by root 3. Okay, so v2 is positive, it means v2 is same as we assume. Okay, what about v1? So here you can say from this equation 2v2 is equal to minus v1. So v2 already we have, so v1 is equal to minus 2v2. So v1 is equal to minus 2 by root 3. So here you get v1 negative. v1 negative, it means this direction should be opposite. So after the collision, they will move with these velocities v1 and v2. v1 is negative. Whatever the direction you assume, the direction of this ball is opposite to that. Okay, very good. Now चलो opposite direction है, बहुत अच्छी बात है. B part हम लोग कर चुके हैं. आगे का पार्ट देखते हैं. आई होप ये समझ गए होगे आप अच्छी तरह से. Now some important things, very important. Impulse of deformation, right? So impulse is applied not on the system. Here impulse is applied on the individual ball only. Okay, so suppose this is the ball, okay, and some impulse is applied on it. Suppose the ball is moving like this, and impulse is applied, and up to the deformation, this is the impulse. Then reformation takes place. So what is the velocity up to the maximum deformation? Maximum deformation. What is the velocity? Obviously 0. So just take any one of the ball. So just take one ball 1. And its mass is 4 kg. So if the mass of one ball, you can say this ball, and its mass is 2 kg, initially it is moving with velocity 4 cos 30, right? And finally it is moved with 0. So impulse is equal to change in momentum. So impulse of deformation is equal to mass, final velocity minus initial velocity. So mass is equal to 2, you can say here. Final velocity is 0. In case of maximum deformation, final velocity we already calculated is 0. So 0 minus initial velocity is 4 cos 30, and when you calculate it, so impulse of deformation you will get minus 4 root 3. Why it is minus 4 root 3? Because you choose this direction as positive. So if this direction is positive, so deformative impulse or impulse of deformation is acting in opposite to that direction. That's why it is negative. Okay guys, very good. Now what is the impulse of reformation? Impulse of reformation, after the deformation, another ball reform and gain a velocity v2. Up to the maximum deformation, the ball has a velocity 0. After the reformation, when they are separated out, that ball has gained a velocity v2 here. दिस v2, राइट, ये v2 मिला था उसको, तो फिर से impulse is equal to change in momentum. Thank you आदिना जोज, थैंक यू. देयर इज अ टेक्निकल प्रॉब्लम, कुछ टेक्निकल प्रॉब्लम थी बेटा कल, इसलिए वो मुझे लैपटॉप से लेना पड़ा था. सेशन नहीं डिले कर सकते थे ना पोस्टपोन कर सकते थे, इसलिए हम लोग ने लिया. आफ्टर दैट पुलकित सर के टाइम तक वो सही हो गया था स्टूडियो. ओके, चलो चले फिर से रिफॉर्मेशन देखो बच्चा. सो रिफॉर्मेशन अगेन फाइनल माइनस इनिशियल कर सकते हैं, बट यहां पर हम आपको एक और फॉर्मूला बताना चाह रहे हैं. सी ई आपने पढ़ा होगा. व्हाट इज ई? कोएफिशिएंट ऑफ इलास्टिसिटी, इंपल्स ऑफ डिफॉर्मेशन डिवाइडेड बाय इंपल्स ऑफ रिफॉर्मेशन. ओके, सो हियर यू कैन से impulse of reformation is equal to E into impulse of deformation. E is given as 1 by 3 and impulse of deformation is minus 4 by root 3. So we can say this is minus 4 by root 3. Okay guys, now we have impulse of reformation, impulse of deformation. We got it. बहुत सारे बच्चों ने ये पहली बार सुना होगा और कैलकुलेट करना भी शायद बहुत सारे लोगों ने पहली बार देखा होगा. What is deformation और what is reformation? कितने लोगों ने फर्स्ट टाइम ये पढ़ा? Just tell me in the chat box. Oh, yes, Tarun, Akshad. Okay, so say thanks to me. Say thanks to me. Okay, chalo, let's move. So impulse of deformation and this is the impulse of reformation we have calculated. Now one more thing, one more new thing. Okay, thank you beta, thank you. चलो ऐसे ही मजे कर रहे थे. Okay, now come to here, maximum potential energy of deformation. Because if the ball is deforming, then some loss of energy, loss of potential energy. Okay, so we have to find what is that deformation, what is that reformation. So E part of the question is maximum potential energy of the deformation. And you know the velocity of the ball at maximum deformation is 0, right? So the energy of the ball at maximum deformation is also 0. So what is the energy that is lost? Means the complete energy is lost. Okay, because velocity is 0. So initial kinetic energy you can calculate it in that direction only. Reformation, deformation, collision, impulse, all things are going on only along the line of impact, right? T axis remains as it is. There is no change in momentum, no change in velocity, no change in kinetic energy along that direction. Okay guys, so now you can say कि if it is, so we have to calculate that energy which is along that direction, and along that direction you have the components of velocity. So energy is half m1 velocity along that line of action is square plus half m2 velocity along that is square minus this is 0. Actually v is 0, so we put v after that 0. So we put the value of m1, value of v1, again the value of dusri, and here the complete energy is 0 because the velocity is 0. And from here you can calculate easily. This is actually the energy of deformation, loss of energy in deformation. जब डिफॉर्मेशन होता है तो डिफॉर्मेशन में एनर्जी लॉस होती है. अब रिफॉर्मेशन में एनर्जी वही मिल जाती है. ओके, रिफॉर्मेशन में वी गेट बैक दैट एनर्जी. डिफॉर्मेशन वी जस्ट लॉस द एनर्जी. इफ डिफॉर्मेशन एनर्जी इज इक्वल टू रिफॉर्मेशन एनर्जी, देन देयर इज नो लॉस ऑफ एनर्जी एट ऑल, एंड दैट एनर्जी इज नोन एज व्हाट? Yes, that energy is, that collision is known as elastic collision if there is no loss of energy. और कभी कभी क्या मोस्टली ऐसा होता है, प्रैक्टिकली ऐसा होता है, द एनर्जी लॉस्ट इन डिफॉर्मेशन डज नॉट कंप्लीटली रिकवर्ड in reformation. Then this is the inelastic collision. And if no recovery of energy, whatever the energy lost in deformation, no energy recovered in reformation, that is known as perfectly inelastic collision. Concept समझ में आया? Hey guys, are you getting the concept? Yes. If there is some energy loss in deformation, if complete energy will recover, अगर recover हो जाएगी, recover हो जाती है, then this is elastic collision. उससे कम recover होती है, then it is inelastic collision. बिल्कुल भी recover नहीं होती है, then perfectly inelastic collision. Got it? And energy of reformation may be equal or less than deformation. Only some special hypothetical case, that is known as super elastic collision. Super elastic collision. And in that type of collision, energy of reformation may be greater than the loss of energy in deformation. That is another case. Got it? Very nice बच्चों. Good response. चलो आगे चलते हैं. Now the loss in kinetic energy. What is that? It's a very simple case. Just find the initial energy, half m1 u1 plus half m2 u2. This is the initial kinetic energy, and remember, along the line of impact. All these things are going along the line of impact. Okay, so you have to concentrate whenever there is a collision. Whatever the velocity of separation and velocity of approach, whatever the conservation of linear momentum, you have to apply along the line of action. Yes, and along the t-axis there is no change. Those components, those velocity, those energy remains intact. उसमें कोई कुछ भी नहीं करेगा. Okay, चलो बच्चों. And now see here. Half m1 u1 value, put this value v1 v2 we have already calculated, and then kinetic energy loss you can see 16 joule. अब देखो एनर्जी का लॉस 18 जूल हुआ था, टोटल एनर्जी का लॉस 16 जूल हो रहा है. इसका मतलब क्या हुआ? 2 जूल एनर्जी क्या हो गई होगी? रिकवर हो गई होगी. 2 जूल की जो एनर्जी होगी वो रिकवर हो गई होगी. दैट इज द एनर्जी ऑफ रिफॉर्मेशन. ओके, चलो इसको हटाते हैं, ये खत्म हुआ. नेक्स्ट चलते हैं आगे, देखते हैं नेक्स्ट क्वेश्चन. और भी अच्छा क्वेश्चन है. यस, सी दिस, वेरी गुड क्वेश्चन. See the question is very good. A very beautiful application of impulse. Very beautiful application of impulse. So please guys concentrate here. A small steel ball A. A small steel ball A suspended by an inextensible thread of length 1.5. इसकी जरूरत पड़ेगी, ध्यान रखना बच्चों. L is equal to given as 1.5. And now another identical ball is thrown vertically downward such that the surface remains just in contact with the thread. मतलब देखो, एक ऐसे बॉल है और दूसरी बॉल ऐसे आती है. इसकी वेलोसिटी सपोज v0 है, ये यहां से आएगी और देखो इससे टकराएगी. ओके, एंड आफ्टर द कोलिजन व्हाट विल, यस डेफिनेटली अक्षत, दिस इज द अनदर कंडीशन ऑफ ऑब्लिक कोलिजन, बट हियर an external force already applied, that is tension, and that tension is impulsive in nature. So we have to apply it very wisely. See here. So after that this ball goes like this with velocity v. Okay, and according to the question, the suspended ball just completes vertical circle. Suspended ball just complete the vertical circle. It means v is equal to under root 5 gl. Okay guys, did you got it? This is root 5 gl. Very good. So this we know. So let's say what we have to do. Yes, see here, this is the center of the first ball and it has velocity v, and that velocity v is equal to root 5 gl. ओके, अकॉर्डिंग टू द क्वेश्चन माय डियर स्टूडेंट्स। ओके, कुछ गड़बड़ दिख रहा है क्या? चलो, this velocity is v and this velocity v is equal to root 5 gl. Okay guys, now one tension applied here, so let's say impulse j dash. Okay, so it has velocity v naught, right? And in similar way, like previous question, you can find the angle, and definitely this angle will be 30 degree. How? Because this center 2r and this is touching, so this is r, so this angle will be 30. If this angle will be 30, so you can say this component is v naught cos 30 degree and this component is v naught sin 30 degree. Okay, so see here is some impulse. See, on this ball one impulse is j dash, and due to this collision another impulse is supposed to be j. Okay, impulse can be denoted by I or can be denoted by j. Here we are denoting by j. So see here, this is the center. So initially this velocity is v naught sin v naught उल्टा हो गया है, yes, ये cos है और ये sin 30 है। चलो यहां बना देते हैं। सो यहां पे this component and another component is this, right? So this is velocity v naught and this angle is 30 degree. So this component is v naught cos 30, this component is v naught sin 30 degree. Okay guys, components लेना समझ में आया बच्चों? या sin 30 and cos 30 because this angle is 30. सही कर दिया बेटा, thanks for correcting Karthik. Okay, now see here, this j impulse applied here, so it will move like this. Okay, so for this you can say this impulse has perpendicular or vertical direction, so you can resolve this j, like this, and here you can say this angle is 30, so along this direction impulse is j sin 30. So first equation, impulse is equal to change in momentum. So initially this ball has no momentum in that direction. That impulse is applied and it has a momentum and the mass of both the balls are same. So first condition you can say j sin 30 is equal to momentum m into v, right? Now sin 30 is 1 by 2, so j by 2 is equal to m into v. From here you can say, चलो आगे देखेंगे उसका जो भी लगना होगा. This is impulse and momentum application for ball first. What about for second ball? See this ball initially has velocity this, and after the collision this component will not change at all. Okay, this component will not change. ये चौक बिल्कुल भी नहीं चेंज होगा. क्यों नहीं चेंज होगा? क्योंकि ये t एक्सिस है और इस डायरेक्शन में कोई कंपोनेंट नहीं है. आफ्टर द कोलिजन इस पे एक कंपोनेंट v2 आ जाएगा. ओके, चलो अब हम लोग यहां पर फिर से इसके ऊपर देखो, एक इंपल्स इसने इस पे j लगाया तो ये भी इसके ऊपर j लगाएगा. ओके, सो इस डायरेक्शन को अगर हम पॉजिटिव ले लें तो इंपल्स j is equal to change in momentum, final minus initial. So what is the final momentum? Final momentum you can say mv2, right? Now guys, ये क्वेश्चन समझ में आई? Okay, video stop, lag, nothing, just refresh your browser guys. Oh, too much lag. Okay, I'm just waiting. just refresh your browser. Refresh your browser guys. चलो, तो गाइज ये इक्वेशन बच्चों समझ में आई क्या, बताओ मेरे को। चलो यहां से हम J डिवाइडेड बाई M इसको लिखेंगे तो हो जाएगा V2 प्लस √3 V0 बाई 2. ओके, एंड अगेन फ्रॉम हियर J बाई M इज इक्वल टू 2V. J बाई M यहां से मिला और J बाई M यहां से मिला, दोनों को इक्वेट कर लेते हैं। तो J बाई M की वैल्यू मैंने 2V रख दी एंड दिस इज V2 प्लस √3 V0 बाई 2. ओके, एंड व्हाट वी हैव टू फाइंड, वी हैव टू फाइंड वेलोसिटी ऑफ V0 in terms of V, because V we already know that is √5 GL. We already know. So one more equation we required, and which is that equation? Because you can see, if you just see this, now you can see here this angle is 30, so this angle is also 30 degree. If this 30, so this angle is 60 degree. So the component of this V is V cos 60, and this component of velocity gained by which component? Which component? क्या reason है इसका, कहां से आया? Due to this impulse, right? So you applied this impulse, and this impulse is also equal to J is equal to V cos 30. Got it? So impulse is equal to change in momentum, and along this direction there is no momentum at all. There is no momentum. So you can say one J by M is equal to this, another J by M is equal to this. Now we have to apply elastic, because the collision is elastic, and if it is elastic collision, it's not tough dear. It's not tough तुषार, J is not tough. डर के आगे जीत है। चलो अब देखो, दो इक्वेशन अपने को मिल गई हैं, दो इक्वेशन में हमने इन दोनों को अप्लाई किया तो फाइनली हम इस इक्वेशन पर पहुंच गए हैं। ठीक है, अब एक हमको और अप्लाई करनी है, कौन सी? elasticity. That elasticity is equal to velocity of separation upon velocity of approach. And this collision, my guys, this collision बच्चों कैसा है? This collision is perfectly elastic. So now you can say E is equal to velocity of separation. So velocity of separation, see, after the collision this ball will move V cos 60 and here V2. So velocity of separation is V cos 60 plus V2. Okay guys, V cos 60 plus V2. And what is the velocity of approach? Along this line, along this line, इसी line, this is the line of impact. See guys, अभी सिखाया मैंने आपको, यहीं पे आप कंफ्यूज होते हो, इसी क्वेश्चन में आप परेशान होते हो, इसलिए मैं सिखा रहा हूं, मुझे पता है ना कि दुखती रग क्या है। तो दिस इज योर दुखती रग। ओके, सो वेलोसिटी ऑफ अप्रोच, वेलोसिटी ऑफ अप्रोच देखो, बिफोर द कोलिजन दिस बॉल विल मूव टुवर्ड्स दिस लाइन विद वेलोसिटी v cos 30. So v cos 30 is the velocity of approach. So E is equal to 1, right? So you can say if E is equal to 1 तो v cos 30 इधर आएगा और cos 30 की वैल्यू v रूट 3 by 2 है, is equal to v by 2 plus v2. Okay guys, हो sir? Okay, now see here v रूट 3 by 2 v by 2 is equal to v2, और यहां से हमको किसको भगाना है? किसको भगाना है? कौन डिस्टर्बिंग है? किसको भगाना है यहां से? v2 को। तो v2 को भगाना है तो v2 को ले आओ, यहां से v2 निकालो बच्चा, यहां से v2 निकालोगे तो 2v माइनस रूट 3 v0 बाई 2 ऐसा होगा। अब यहां से v2 देखो बच्चों, यहां से v2 देखोगे तो v रूट 3 बाई 2, देखो वहां से क्या हुआ, v रूट 3 बाई 2, हाँ, इसको इधर लाओगे तो क्या होगा बेटा, माइनस v बाई 2। जिसको जहां भगाना वहीं ले आए ना। अब अपने को v नॉट v की चाहिए, बस यहां देखो, अब इसको उधर भगाओ, इसको इधर लाओ। v बाई 2 प्लस 2v कितना होगा? यस 5v बाई, देसी स्टाइल में देखो ना, 2v और आधा v, 2 और आधा ढाई, ढाई मतलब 5 बाई 2। ओके चलो इधर √3v नॉट और उधर जाके √3v नॉट बाई 2, √3v नॉट बाई हो गया √3v नॉट। ओके गाइज, नाउ वी हैव टू फाइंड व्हाट v नॉट। तो v नॉट इज इक्वल टू, अब बहुत जगह है, इसको मिटा दे क्या? नोट तो कर लिया होगा, नहीं नोट कर लिया तो वीडियो को पॉज करना बाद में, हाँ उसके बाद करना। चलो अब इसको यहां से हटाते हैं, अभी देखो सारी वैल्यू मिल जाएगी, डोंट वरी। नाउ v नॉट अपने को पता करना है, तो v नॉट इज इक्वल टू 5v और बाई 2√3। ओके, नाउ v √5gl है, तो 5 बाई 2√3 अंडर रूट 5gl, 5gl। तो 5gl में देखो बेटा 5 है, g की जगह 10 है, और बताओ l कितना था? मैंने कहा था याद रखना, नहीं याद रखा, l था 1.5। ओके, अब देखो 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 यहां 15 इंटू 10 कितना हो जाएगा? 15 इंटू 10 बोलो, 15 इंटू 10, देखो 15 इंटू 10 कितना हो गया? 15। 15 इंटू 5, 15 इंटू 5 कितना हुआ? 75। 75, तो 5 डिवाइडेड बाय 2√3। अब √75 को लिखा 25। देखो जल्दी, ये रूट आया था ना, √75, इसको लिखा 25 इंटू 3 और उसका 5 बाहर उठाया और ये √3 बनाया। ओके, तो इसको लिख सकते हैं बच्चों 5√3। अब देखो √3 से कैंसिल, 5 इंटू 5 25, 25 बाई 2 इज इक्वल टू 12.5 एंड 12.5 इज द आंसर। कहीं लिखा होगा यहां? नहीं। सो नोट डाउन, आंसर ऑफ दिस क्वेश्चन इज 12.5। यस, 25 बाई 2 12.5, ये आंसर मैंने कहीं लिखा होगा, देख लेते हैं इसको। देखो बच्चों, हाँ अरे भाई क्या हुआ? ओके, अनदर क्वेश्चन। यस, सी दिस guys. See this, 12.5 मीटर पर सेकेंड और 12.5 मीटर पर सेकेंड हम लोग कैलकुलेट कर चुके हैं। ओके, सो इसका आंसर 12.5 है। चलो देखते हैं अब आगे कौन सा क्वेश्चन है। आगे और एक अच्छा क्वेश्चन आया है, इसको भी सॉल्व करते हैं। This question is also a good question. See here, rod AB, this circle is fixed. This circle is fixed. ये सर्किल पूरा फिक्स है और इस सर्किल के ऊपर एक रॉड है and that rod is moving with a given velocity on a circle. Okay, this circle, this rod and this rod is moving like this, ऐसे जा रहा है। Now you have to find velocity of this point P. Okay, see here, this is a question. A rod AB is moving on a fixed circle. Rod AB is moving on a fixed circle with radius r with a constant velocity v as shown in figure. P is the point of intersection of the rod. At the instant the rod is at a distance 3r by 5. This distance is given as 3r by 5. At that particular distance, the velocity of rod is perpendicular to the rod and the rod is always parallel to the diameter CD. You have to find V. Very easy question. Just as you can see, the velocity of this should be like this. This is the velocity of P. Okay, if you resolve this velocity in two components, okay, two component, now you can see one component is here and one component is here, and Before that we have to find the angle, and here you can say this angle is this, because this is r by 5, 3r by 5, this is 3r by 5 and this angle is r. तो ये एंगल कितना होगा बच्चों? ओके, r, if this angle is theta, so you can say r cos theta is equal to 3r by 5. So this r will be cancelled, so theta you can say 53 डिग्री. ओके, चलो अब इसको देख लेते हैं. सॉल्व किया हुआ है तो इसको देखते हैं. यहां से अगर ये एंगल थीटा है, दिस एंगल सपोज टू बी थीटा, सो दिस एंगल इज 90 माइनस थीटा, दिस एंगल इज थीटा अगेन. यू कैन टेक द कंपोनेंट दिस डायरेक्शन, द कंपोनेंट इज वीपी साइन थीटा, एंड हियर यू कैन से दिस इज वीपी कॉस थीटा. वीपी कॉस थीटा की जरूरत नहीं है, और दिस कंपोनेंट एक्चुअली दिस v. So you can say v is equal to, here you can say v is equal to vp sin theta. So vp is equal to v cosec theta, and cosec theta we already calculate theta, was just put the value of cosec theta, theta 53, so cosec theta 5 by 4, and we'll get vp is equal to 5 by 4. Easy type of question, you can easily find out. Okay, now let's see. Yes, another good question. A particle, see here, has mass small m. Simple pendulum is vibrating. Simple pendulum जानते हो, ऐसे ऐसे वाइब्रेट कर रहा है. Simple pendulum is vibrating, angular amplitude of 90 degree. Angular amplitude मतलब ये यहां से ऐसे यहां तक 90 डिग्री तक जाता है. ओके, एंड सी द गिवन फिगर फॉर व्हाट वैल्यू ऑफ अल्फा. अल्फा पता करना है. एक्सीलरेशन वर्टिकली अपवर्ड. हाउ मेनी टाइप्स ऑफ एक्सीलरेशन आर देयर? बिकॉज दिस इज अ पार्ट ऑफ सर्कुलर मोशन. Part of circular motion, and if it is a part of circular motion guys, then it has definitely centripetal. Yes, two acceleration. Very good. अरे वाह, अक्षत, आकाश, तरुण. What type of acceleration? Centripetal acceleration, tangential. Yes, very good. Radial and tangential. So see, for the first part, vertically upward. So vertically upward means no horizontal acceleration. And this is possible only when it is at lowest point, means when alpha is equal to 0. When alpha is equal to 0, so this has v square upon r. No this acceleration, because no component. Tangential acceleration किस वजह से आएगा? mg के g के component, and if there is no component of g in that case, so only the vertical. So first is for this one, अल्फा शुड बी 0. हॉरिजेंटल हो, चलो हॉरिजेंटल वाला कैलकुलेट करेंगे. थर्ड आसान है, उसको देख लेते हैं. वर्टिकली डाउनवर्ड. वर्टिकली डाउनवर्ड इज द सिचुएशन व्हेन मास इज हियर. ओके, दिस इज द सेंटर एंड अल्फा इज इक्वल टू 90 डिग्री. सो वेलोसिटी हियर 0. इफ वेलोसिटी इज 0 गाइज, अगर यहां वेलोसिटी 0 है बच्चों, तो सेंट्रिपिटल एक्सीलरेशन नहीं होगा. ओनली इधर कौन सा एक्सीलरेशन होगा? g. सो द आंसर ऑफ थर्ड पार्ट कितना होगा? सी हियर, थर्ड पार्ट अल्फा इज इक्वल टू 90 डिग्री. ओके, नाउ द इंपॉर्टेंट पॉइंट इज case 2 is never possible. Why case 2 is not possible? Case 2 never possible guys. Akash Gupta is saying case 2 is never possible. Why it's not never possible? Just I am showing you. I will show. See here. First case is second case. See, this is center. This angle is supposed to be alpha. Let me change the color. Now suppose at this position it has a velocity v. So it has a velocity v, so it has acceleration V square divided by R. Okay, and what is the distance? This distance is R cos alpha. Okay, and here this direction acceleration is G sin alpha. Okay, so at particular position, this is, yeah, it is possible, Akash. So at this position you can see V square upon R and G sin alpha are there. And what is the requirement? The requirement, bachcho, is that acceleration, the resultant of these two must be horizontal. Yes, if this is a requirement, then you can say if this is horizontal, then definitely this 90, this is alpha, this 90 minus alpha, so that should be alpha. Okay, so you can see in this triangle tan alpha, what you can say? Tan alpha is equal to perpendicular upon base. So for this triangle, perpendicular is V square upon R, and base is equal to, my dear students, is G sin alpha. Okay guys, yes. Two fact forward 2. No, not 2. See, tan alpha and now V square upon R is equal to G sin alpha into tan alpha. Now we have to find V. From where V comes here? V kahan se aaye? Case 2 and 3 again. Case 2 I am explaining, just concentrate here. 4 also not possible. Where is cause 4? Rao Sahab Yadav, where are you? There is only 3 cases. 1, 2, 3. Okay, no case 4. And now dear, see here, V square comes from where? Just the loss of energy and gain in kinetic energy. Okay, yes, definitely we'll get. See here, concentrate here guys. So from here to here, loss in energy, potential energy, mgr cos alpha, and is converted into kinetic energy, that is half mv square. बोलो भाई, अरे tan मिलेगा भाई, tan थीटा मिलेगा, डोंट वरी आकाश. राव साहब, you are in class 11. अच्छा, if you are in class 11, though instead of 3 you are seeing 4. What is the logic, राव साहब? चलो देखो इधर. Now we have to find V square upon R. So V square upon R, we get V square upon R from here. See here, 2 mg cos alpha. Okay, R यहाँ आ गया और इसका 2 वहां चला गया. अब V square upon R की जगह you can put 2 mg cos alpha is equal to G sin alpha. Again tan alpha is sin alpha upon cos alpha. Okay, there is something garbad. Okay, sorry, m and m will be cancelled out, so there is no m at all, so here should not be m. Okay, now G will be cancelled out, and cos sin square alpha upon cos square alpha is equal to tan square alpha is equal to 2. So tan alpha is equal to बच्चों root 2. Alpha is equal to tan inverse root 2. Okay, Rao Sahab? Yes, Rao Sahab. Just concentrate on the screen. Okay, this is only the way. Just practice question. So this is the answer for third case, and for all other case we have done 1 and 2. So let's see some more of the question. Yes, these are the cases. Oh, very nice question. Yes, SCV का क्वेश्चन है. SCV में आंसर गलत है, तो यहां पर हम लोग इसको करेक्टली करते हैं. दिस इज अ वेरी वेरी गुड क्वेश्चन, एंड हियर यू कैन लर्न अ लॉट ऑफ थिंग. Okay, Rasov, don't worry, because you might not studied this all. See here, there is a cart of mass capital M. Okay, and two ends there are two divers M and M are standing here. One jumps with velocity u with respect to cart, then another jump with velocity u with respect to the cart, and you have to find yes SCV, you have to find the correct value of velocity when both has jump. ओके दोनों जंप कर गए हो तो हमको वेलोसिटी चाहिए, एंड इट्स नॉट द कंसेप्ट ऑफ रिलेटिव मोशन डियर. ओके सो लेट्स सी हियर, चलते हैं. कंसेप्ट आपको समझ में आ चुका है, अब वो कंसेप्ट सॉल्व कैसे होगा वो देखते हैं बच्चों. सो फर्स्ट कंडीशन सी हियर, दिस इज मास m and one mass small m and another mass small m jump with velocity u, and here the concept start. यहां से कंसेप्ट स्टार्ट होगा. यस, कंजर्वेशन ऑफ लीनियर मोमेंटम. सो अब यहां से देखो बच्चों कि इसके जंप करने के बाद कार्ट किधर भागेगी. ये जो कार्ट थी कैपिटल एम मास की, एंड इट इज फ्री टू मूव ऑन अ हॉरिजॉन्टल सरफेस, रिक्वायर किधर होगी. ओके ये रिक्वायर किधर होगी, ये रिक्वायर इधर होगी विद वेलोसिटी v, एंड इट विल गेन अ वेलोसिटी u माइनस v. आधे लोगों को ये समझ में नहीं आया होगा. ये कंसेप्ट ठीक है बच्चों? डिड यू गेट इट परफेक्टली? डिड यू गेट इट परफेक्टली गाइज? जस्ट टेल मी, डिड यू गेट इट और नॉट? यस, एनसीईआरटी कंसेप्ट, वेरी गुड. क्योंकि ये जंप कार्ड के रिस्पेक्ट में यू से किया, ऐसे जंप किया. अब पीछे अगर जिस पे खड़ा है वो अगर पीछे चली गई तो उसको एग्जैक्ट उतनी वेलोसिटी नहीं मिलेगी, यू वेलोसिटी नहीं मिलेगी. यू वेलोसिटी इज विद रिस्पेक्ट टू कार्ट. ओके सो विद रिस्पेक्ट टू ग्राउंड इट्स वेलोसिटी इज u माइनस v. नाउ अप्लाई द कंजर्वेशन ऑफ लीनियर मोमेंटम बिकॉज इनिशियली दे आर एट रेस्ट. If they are at rest, so their linear momentum is 0. If their linear momentum is 0, so now their linear momentum should be 0 now. Okay, so you can say m u minus v is equal to capital M plus m into v. Okay guys, हिंदी में भी बोलिए. अरे बोल तो रहा हूं हिंदी में. बोल रहा हूं, डोंट वरी. सो गाइज एम यू वी, सो नाउ वी हैव टू फाइंड वी. सो व्हाट विल डू, एम यू माइनस एम इंटू वी इज इक्वल टू कैपिटल एम प्लस एम इंटू वी. सी इट विल गोज हियर. सो यहां एम यू होगा, ये एम वी इधर जुड़ेगा, तो कैपिटल एम प्लस ट्वाइस ऑफ स्मॉल एम इंटू वी, एंड दैट वी दैट यू विल गेट m into u divided by capital M plus 2 small m. This is the velocity of that kart after first jump. Okay guys, after first jump. Okay, राव साहब what you are asking? राव साहब आप बहुत परेशान आत्मा हो. हाँ, why you are here disturbing? Here I am just solving the question बेटा. सो आपको बीच में मैं ये नहीं बता सकता हूँ. उसके लिए आप, मेरा व्हाट्सएप नंबर आपका होगा, और कमेंट बॉक्स में आपके पास जो भी क्वेरी है, आरव एंड राव साहब, वट एवर यू एनी क्वेरी डू यू हैव, जस्ट पुट इन कमेंट बॉक्स. डेफिनेटली आई विल आंसर. आई विल रिप्लाई देयर पर्सनली. आई विल रिप्लाई. जस्ट पुट इन कमेंट बॉक्स. और एनी अदर गाई, if you have any type of problem, just put your query on the comment box. I will definitely reply. ओके चलो अभी क्वेश्चन पे ध्यान दो. अभी क्वेश्चन का टाइम है राव साहब, अभी क्वेश्चन का टाइम है. ठीक है, आप उसमें रख देना, कमेंट बॉक्स में आप लिख देना, डिटेल में लिख देना, और मैं डिटेल में पूरे विस्तार से आंसर दूंगा. ओके चलो. Ahina, it is given that they are jumping with u, right? Yes, this is given question. They are jumping with velocity u. Adina Jose, I already explained, so आप please see the replay why it is u minus v, why it's not u, and now I'm going to explain again. See here guys, what is the second condition? The second condition is this cart m already moving with velocity v and small m is on it. Okay, after the jump, this mass m has velocity v dash and this mass m has velocity u plus v dash. Did you got it, guys? Anna Jones and other people, did you got it? Is u zero? No, guys. No, beta. Anirudh, it's not zero. No, we cannot do it by energy conservation. We can do it only and only by conservation of linear momentum, and that I am applying also. Conservation of linear momentum. Okay. So guys, क्या ये बात समझ में आ गई? Very good. Thank you. Thank you. Cool confused. What is your name? Cool confused teen. Karthik Mudaraddi. Okay. Very good. Why not u plus v? Yes. V is the velocity before jump. Okay. And v dash is the velocity after jump. This is the concept. When it jump, तो it acquire the velocity after the jump. और इसको समझने के लिए suppose there is a slippery, there is a surface. Suppose you are standing on a stool, okay, and that stool is resting over the road, where there is a sufficient friction. And suppose वो slip नहीं करता है, suppose वो slip नहीं करता है. Not bus. Just listen. I am just explaining. Suppose एक फिक्स स्टूल है और फिक्स स्टूल पे आप एक कॉर्नर पे खड़े हो, हाँ, और उस कॉर्नर पे आप ऐसे जंप करते हो, ठीक है? क्या आप जितनी जोर से जंप किए हो उतने आगे जाओगे? जस्ट टेल मी. डेफिनेटली जाओगे, बिकॉज जहां पर आप खड़े थे वो स्टूल स्लिप नहीं किया पीछे, वो स्टूल फिक्स्ड है, रिजिडली फिक्स्ड है. सो जितनी भी आपने पावर से जंप मारा है आप आगे जाओगे, डेफिनेटली जाओगे. बट सपोज इफ दैट स्टूल इज रेस्टिंग ऑन ए फ्रिक्शनलेस सरफेस, सपोज आइस, हाँ, सॉलिड आइस पे रखा हुआ है या फ्रिक्शनलेस सरफेस पे रखा है. अब आप उस स्टूल पे जंप करते हो आगे यूं, और जैसे ही आप जंप करोगे आपके पैर पीछे स्लिप कर जाएंगे. तो क्या अब आप उतनी डिस्टेंस आगे जंप कर पाओगे या नहीं? जस्ट टेल मी. नो, यू कांट, बिकॉज जैसे ही आप जंप करोगे वो स्टूल पीछे मूव कर गया. तो स्टूल पीछे मूव कर गया जिस वेलोसिटी से, आपको रिलेटिव वेलोसिटी उस स्टूल के बाद वाली मिली ना, क्योंकि स्टूल पहले तो रेस्ट पे था. अगर पहले वाली वेलोसिटी मिली तो आपको u मिलनी चाहिए थी, लेकिन अगर v से पीछे चला गया स्टूल तो आपको u माइनस v मिली, यानी जंप करने के बाद. ओके, सो आई होप यू गॉट अंडरस्टूड. समझ गए बच्चों? वेरी गुड. आरव, अमृत राज, विजुलाइज, मन की आंखें खोलो. अमृत राज, मन की आंखें. यस, बिकॉज आपने जो जंप किया उसकी कुछ एनर्जी स्टूल के पास भी चली गई. सो ऑब्वियसली जो एनर्जी है वो आपको कम मिलेगी. ओके, वी डैश की डायरेक्शन हम कुछ भी ले सकते हैं. ओके गाइज, ओके गाइज, थैंक यू. सो नाउ यू कंप्लीटली अंडरस्टूड कि देखो यहां पर भी ये रेस्ट पे था, लेकिन जंप करने के बाद इसकी वेलोसिटी v हुई थी, तो इसको v वेलोसिटी मिली थी ना कि वो रेस्ट वाली. ओके, सो हियर इनिशियली इसकी वेलोसिटी v है. So after the jump its velocity is v dash. So the velocity should be u plus v dash, not u plus v. This is the conceptual part behind the question. This is the conceptual part and this is a very good conceptual question. Okay guys, चलो अब इसको सॉल्व कर लेते हैं बच्चों. हाय यशदीप. ओके, सो देखो इसके पास अभी कितना मोमेंटम है, कैपिटल M प्लस स्मॉल m इंटू v, और उसके पास कितना हुआ mv डैश प्लस u प्लस v डैश इंटू स्मॉल m. नाउ यू कैन से m प्लस स्मॉल m v की वैल्यू हम अभी रख लेंगे अभी यहां से देखो m प्लस स्मॉल m इसको और इसको इंटू v डैश प्लस m इंटू u. Okay, now we have to find this. So see, m plus small m v dash is equal to capital M plus small m. Now v is m into u divided by capital M plus 2 small m and minus mu. Minus mu. Okay, now you can solve it easily. Okay, you can solve it. Thank you Yashdeep, thank you so much. Now you can solve it and you will get definitely answer. I already calculated it, I can show you. So just you, after that you can pause the video, you can solve it, you can note it, and also you have a question. See here. Yes, this is the solution. This is the first calculation. Okay guys, and now you can see another calculation, and this is the answer that you will get very easily. Okay, this answer you will get very easily. So I hope you completely understood guys. चलो आगे चलते हैं. एक और अच्छा क्वेश्चन था, नहीं इससे पहले, हाँ देखो, spring question, spring. Okay, spring mass system, this is a very good question, and the concept behind this is, if there is no any external force, then the linear momentum of the system remains conserved, right? If there is no any external force. So here is the case. Yes, definitely guys, I promise that I will put this as a PDF form in the description box. आज का भी और इससे पहले वाले सेशन का जो कल का भी है, दोनों को मैं डिस्क्रिप्शन बॉक्स में डाल दूंगा, आप वहां से इसकी PDF डाउनलोड कर लोगे. ओके, प्रॉमिस. और अगर नहीं होता है तो आप मुझे कमेंट में एक दो बार कमेंट कर देना, सभी लोग, याद आ जाएगा मुझे, एंड डेफिनेटली मैं इसको PDF फॉर्म में डाल दूंगा. ओके गाइज, एनर्जी मे और मे नॉट बी कंजर्व, बट लीनियर मोमेंटम शुड बी कंजर्व. ओके गाइज, सो सी, दिस इज अ क्वेश्चन दैट A and B have a masses 40 and 60 kg respectively. They are placed on a smooth surface and the spring connected between them is stretched by 1.5 meter. Stretched by 1.5 meter. Initially it is stretched, right? And friction is absent. Initially when it is stretched, so now you can say if they release from rest, what is the speed when at the instant when a string becomes in its natural length. Okay, here in this question, yes, friction is absent, so energy is conserved. Now you are right, Yash, now you are absolutely right. Okay, Karthik, yes, very good. About the center of mass, definitely if there is no any external force, then the center of mass remains at rest. बिल्कुल सही है, बिल्कुल सही है. Now, so if at that instant when it is at rest, it has a velocity v1 and it has a velocity v2. So initially the linear momentum is 0. So at each and every point, because there is no any external force, because spring is a part of the system, and if spring is a part of system, then it is the internal force, and it is the internal force, so though no external force, so the linear momentum should be conserved. And before that linear momentum is 0, so after linear momentum should be 0. So you can say that m1 v1 minus m2 v2 should be 0. So m1 v1 must be equal to m2 v2, and here m1 is 40, v1 is equal to m2 60, v2. So you can say v1 is equal to 3 by 2 v2. This is the relation between them. Okay, so guys, when a spring is stretched by 1.5, so it has a potential energy stored in it half kx square. This is the potential energy stored, and ball and blocks are at rest, so velocity is 0, kinetic energy is 0. Now when the spring is in its natural length में जब आएगी तो इसकी potential energy 0 हो जाएगी, but loss of potential energy is converted into gain in kinetic energy. So if the gain in kinetic energy, dear student, so the kinetic energy gain is half m1 v1 square plus half m2 v2 square. Did you got it? Why 0? What is 0, Yash? What do you mean to say 0? Yes, loss in potential energy is equal to gain in energy, kinetic energy. So this is the loss in potential energy and this is a gain in kinetic energy. Very good. And now yes, block will move with SHM. Yes, you are absolutely right. They will move like this. Very good. Thank you. And you have the relation between V1 and V2. Just put the value V1 and V2 and then you will get good answer, exact answer. Okay. So I hope you understood. Thank you. ओके, चलते हैं बच्चों आगे, और ये है सॉल्यूशन, उसका आंसर भी आपको मिल जाएगा। V1 V2 ये V2 3 है एंड V1 4.5 है। सो यू विल डेफिनेटली गेट दिस एज ए PDF. You can download the solution. And one more question that is a very easy and also very conceptual one. इसीलिए मैंने इस क्वेश्चन को लिया है because it is a very conceptual. Okay. And its answer is 3. कार्तिक. ओके, सो कार्तिक बहुत तेजी से कैलकुलेट किया तुमने, वेरी नाइस. चलो, द क्वेश्चन इज देयर आर 2 balls A and B having same mass and they are put like this. Okay, mass M and the length is L. And it is given some velocity supposed to be u, and that u is given as 4√3, guys. Okay, initially the string is slack, no tension, but when you just throw it, the string will up to this instant, when it will reach here, the string will be like this when it will taut, ऐसे होगी. Okay, तो होगा क्या? सो जैसे ही ये वेलोसिटी u है, हाँ, तो अब इसके ऊपर क्या होगा? इंपल्स लगेगा, एक इधर से इंपल्स लगेगा और एक इस पर इंपल्स लगेगा. गॉट इट? एंड द कंपोनेंट, एंड हियर if this is L and this is 2L, then definitely you will get this angle as a 30 degree. Okay, now you can extend it, right? And if you extend, if this angle is 30, so this angle is also 30, and this component you can say u sine 30. Okay, and u sine 30 will not change at all. U sine 30 here will not change at all. Why will not change? Because the impulse is perpendicular to this component. Only the component will change, that is u sine 30. So before that, linear momentum is mu sine 30. After that, when a string become taut, it will move with v, and this string cannot extend, so this is also move with v. Now apply the conservation of linear momentum. अब क्या अप्लाई करेंगे हम लोग? Linear momentum. So before the string were taut, जब string taut नहीं थी, उससे पहले, yes, very conceptual but very easy. So उससे पहले इस डायरेक्शन में मोमेंटम कितना था बेटा? उस डायरेक्शन में मोमेंटम था mu sin 30. ओके, इस डायरेक्शन में मोमेंटम mu sin 30 था. अभी क्या हो गया है इस डायरेक्शन में? देखो, m into v, और फिर इसके पास भी ये वेलोसिटी होगी m into v. ओके, नाउ यू कैन से, लेट्स चेंज द कलर so that you can understand. mu 1/2 is equal to 2mv. So now m will be cancel out and V is equal to, see here, V is equal to U by 4. Okay, this is M, here M will cancel out, and now you can put value of M here, U that you have already. So 4 by 3 you can cancel out, and this is the velocity. You have to find net velocity, so U sin 30, and this is U sin 30. So definitely component. Okay, let's see the component. Oh, yes, my mistake, sorry guys, because angle is different. Okay, so here we'll get U cos 30 and here U sin 30. Okay, so U sin 30 will not change. Okay guys, yes, it's a mistake, sorry. So U will not change. Now here you can say it's MU cos 30. Here should be cos, so here should be U root 3 by 2 and this is 2 MV. So here what we'll get? 2V. So V is equal to U root 3 by 4, right? Okay, now it's okay. Okay guys, now U we have, what we have as a U? You have 4 root 3 into root 3 divided by 4. This 4 will be cancelled out, so root 3 will be 3 meter per second. So it's a easy question guys, but the conceptual one. Okay, so answer is 3 meter per second. Got it? Very good. चलो अब एक और देखते हैं कि आपने पास कोई आगे क्वेश्चन है. अरे वाह, this is the last question guys, this is the last question. Okay Roman, you are from USA. Okay, welcome to India. Oh, so guys, this is a very good and very conceptual or very must question. Matlab I can say must and must question. Okay, yeah, I can teach in Hindi, but Roman, just see. Okay, so see here, this is a very good question. Actually the question is, a small ring A of mass m is equal to 1 by 2 kg attached at the end of light string. This is the mass, this is a very light string, and this is a ring, end of which is tied to a block B of mass 2m. The ring is free to move and fixed or smooth rod, मतलब इस rod में friction नहीं है, ठीक है, सॉरी जीरो है. तो गाइज बहुत ध्यान से देखना, very good and must question, and this is the last question of the day. Okay guys, so please be concentrated, but question मस्त है, मजा आ जाएगी. हाँ, तो देखो हुआ क्या, यहाँ फ्रिक्शन नहीं है और ये 2m ब्लॉक है, and this mass has a small m mass, and now when we release it, what is the motion? The motion will be finally like this. So can anybody say, is it correct? Is it correct guys? Yes, circular motion, but the path that I made here is correct. Just tell me. No. Why? Ajay Pandit saying no, and Anirudh yes, Piyush no. Why no? Can anybody tell? Can anybody tell what's the wrong with it? Ring will also move, yes. And the most important thing, as there is the external force only in vertical direction. External force कहाँ है? सिर्फ vertical direction में है. So center of mass can move only in vertical direction. So dear, if this is m, this is 2m, so its center of mass may be somewhere else. Okay, so center of mass can move only and only this line on vertical, because on vertical there is mg. There is no force in horizontal direction, और horizontal direction में कोई force नहीं है. It means center of mass should not move in horizontal direction. So what should be the correct? So see here, the correct position is this ring will be here and a string will be like this, and mass 2m will be here, okay, and its center of mass will be here somewhere. Oh, and its velocity is supposed to be u, and its velocity is supposed to be v at that instant. Okay, so there is hi Roman, yes, my name is Shadab. Okay, my name is Shadab. Okay, chalo. Now guys, you can see here, if this velocity is 2mv, this velocity 2m, there is no horizontal force, so horizontal linear momentum should be conserved. Horizontal linear momentum should be conserved. So you can say m into u must be equal to 2m into v, right? So 2m into v, m, this mass is m into u, they are in opposite direction, that's why I equate them. So m will be cancel out, and now you can say u is equal to 2v. तो u के पास जो velocity होगी वो 2v होगी. Now we have to find the tension in a string. Okay guys, we have to find the tension. For tension we need this velocity, and from where this velocity? Yes, energy conservation. So the loss in potential energy, my dear students, is 2mgl, right? This is the loss of potential energy, and this loss of potential energy is converted into where? This loss of potential energy कहाँ गई, किधर convert हुई? This loss of potential energy is converted into kinetic energy. Kinetic energy, guys. Kinetic energy. Oh, centrifugal force. Who says that? Yes. It's not centrifugal. How can you equate the energy and force? What is this? Kinetic energy. Kinetic energy of this mass and kinetic energy of this mass. So let's say kinetic energy half 2mv square plus half m 2v square, that means 4v square. So here you can say 2mgl is equal to 2 will be cancel out, and here 2mv square plus 2mv square is equal to 3mv square. Got it? So now m will be cancel out, so v square is equal to 2gl divided by 3. This is the value of v square. Okay, we need it, then we use it. Now the centripetal force. Okay, so now we apply the equation for centripetal force. See here, at this position downward force is 2mg, right? So T, okay, minus 2mg is equal to T minus 2mg, provide the required centripetal force, obviously 10. So what is the centripetal force, guys? What is the required centripetal force? Just tell me. Required centripetal force, guys. Anybody? Is it mv? It is 2mv square by r? No, no, because due to this movement with respect to this, velocity is not v. The conceptual part, guys, conceptual part, its velocity is not v, its velocity is 3v. Its velocity is 3v, guys. Just see here, because when you assume this ring to be at rest, so this velocity 2v, due to relative motion you have to impart it here. So this, with respect to this ring, the velocity is 3v. So the centripetal force, my dear students, 2m v, v is 3v square divided by L. So T is equal, T minus 2mg is equal to 3 3s are 9 to 18 m v square by L. Okay, now you can say T minus 2mg is equal to 18 m by L. Okay, v square that you have V square, what do you have? V square, see here, from here V square we can say 2GL by 3. Okay guys, now see 3, 6, L will be cancel out. So 6 into 2, 12, 12G. Okay, 12 mg. So from here you can say T is equal to 12 mg, 2 into 6 into G into M, 12 plus 2, that is 14 mg. Okay, so now you can say 14, M is equal to 1 by 2, G is equal to 10, so 2, 5 and 14 5s are 70 Newton. So guys, answer for this is 70, and you can see, right? Not tricky, really a very good conceptual question. Thank you Roman, so much, thank you so much, and all other guys, thank you so much. Answer is 70 Newton, and here is the answer, here is the calculation, here you can see 70 is the answer. Okay, so guys, I hope you enjoyed a lot. बहुत मजा आया होगा, और मुझे भी इस सेशन में बच्चों बहुत मजा आया आपके साथ बात करके, एंड थैंक यू फॉर योर सो ओवरवेलमिंग रिस्पॉन्सेस. बहुत अच्छे से आपने रिस्पॉन्स दिया, बहुत अच्छे से कनेक्शन हुआ, और बहुत अच्छे से आप हर बात का आंसर दे रहे थे. दैट इज वेरी गुड, वेरी गुड. ओके, थैंक यू. कैन यू क्लियर माई डाउट? Can you ask if anybody, if you have any type of doubt, just put in comment box. Just put in comment box. I will personally answer. Definitely I will personally answer. Okay? And इससे पहले कि जितने भी सेशन में जितने भी डाउट्स आपने पूछे हैं कमेंट्स में, मैंने सबका पर्सनली आंसर किया है, यहाँ पर भी करूँगा, और डेफिनेटली मैं इसको PDF में कन्वर्ट करके डाल दूंगा. Okay, and thanks for love and support guys, and thank you for your valuable time. I hope सभी का एडवांस का एग्जामिनेशन बहुत अच्छा हो. So guys, please do very hard work, and remember कि जिस दिन वो रिजल्ट आएगा, वो रिजल्ट वाला दिन याद रखो. एक रिजल्ट आएगा IIT का, उस दिन आप IIT वेबसाइट पे जाके रिजल्ट अपना देखोगे, उसमें एक बॉक्स होगा, उसमें बॉक्स में आप अपना रोल नंबर एंटर करोगे, है ना, और रोल नंबर एंटर करने के बाद फिर आप जस्ट एंटर दबाओगे, उसके बाद एक स्क्रीन आएगी, राइट, और फिर उस स्क्रीन से जिंदगी, बहुत ज़्यादा नहीं कहूँगा, हो सकता है बैकग्राउंड में म्यूजिक चलने लगे, जग सूना सूना लगे, है ना, और या फिर बैकग्राउंड में ये भी चल सकता है, आज मैं ऊपर आसमान नीचे. यस, वेदांतु इज वेरी यूजफुल. all the things which teach you anything, कोई भी चीज, कोई भी पर्सन जो भी आपको जरा सी भी चीज सिखा सकता है, भले ही वो 2 पॉइंट सिखा सकता है, डेफिनेटली वो आपके लिए बहुत इंपॉर्टेंट होता है ना. कब पता नहीं कहां कौन सी छोटी सी चीज कहां पर काम आ जाए. तो इसलिए बस सीखते चलो, चारों तरफ ज्ञान की गंगा बह रही है ना, उस ज्ञान की गंगा में बस गोते लगाते रहो, जहां से जितना मिल सके उतना सीख लो, और यही लर्निंग फेस है, और यही आपको आगे ले जाएगा डेफिनेटली. सो आई होप यू एंजॉयड द सेशन, एंड नेक्स्ट सेशन में फिर से मिलेंगे कुछ मस्त और मस्ट क्वेश्चन के साथ. टिल देन, बाय बाय, टेक केयर, सावधान रहें, सतर्क रहें, मोटिवेटेड रहें, स्टडी करते रहें, और अपने उस लास्ट डे को, जिस दिन आपका रिजल्ट आने वाला है, उसको याद रखें, और ये भी याद रखें कि आपने IIT की तैयारी क्यों शुरू की थी, व्हाई यू स्टार्टेड. ओके गाइस, थैंक यू, बाय बाय, ऑल द बेस्ट बच्चों, ऑल द बेस्ट, थैंक यू.